two last things here to cover. So the first thing is the dot product. So that's very important. When they talk about the dot product, it is going to look like it's just basic multiplication. So when they say u times v, we are using the dot product here. So what you're going to be doing, so if u is u1, u2, and v is v1, v2, you're going to do the dot products. You're actually not going to end up with a vector. You're going to end up with just an answer. Okay, so just a single integer or number. So when you do the dot product, you are multiplying u1 times v1. So in other words, multiply your x values together, but then it's plus, and then you're going to multiply your y values together. Okay, so you should end up with a value, not a vector. So when we're looking at these examples here, if we do the dot product of this vector, okay, so we have dot in the middle, dot product, you're going to do 3 times 5 plus, then you're going to do 4 times 2. Okay, this is not like FOIL or anything like that. It is just the dot product. So we're going to end up with 15 plus 8 will give us an answer of 23. So we end up with a scalar number, okay, instead of a vector. So if you look at B, we're going to do the same thing with dot product here. So when you're doing the dot products, you're going to be multiplying this 1 times negative 4 plus this negative 2 times 3. So we'll have negative 4 plus negative 6. So you should end up with negative 10. Okay, so when you add two vectors, you end up with another vector. If you have a k outside, so a scalar number outside, you end up with a vector. But if you do the dot product, so you have a vector times a vector, you end up with a scalar number, not a vector. Alright, last slide. So orthogonal and parallel vectors. So guys, first off, just think about this as being parallel and perpendicular. Okay, same thing, just orthogonal is the word that we're using here for the perpendicular. So orthogonal versus parallel. So two vectors are going to be orthogonal if their dot product is 0. That's the only time that they're orthogonal. Parallel, two vectors are going to be parallel if you can multiply some constant k by one vector to get another vector. Okay, so parallel, you have to be able to multiply. If you can't do either of those, then it's just going to be neither. Okay, it doesn't have to be one or the other. It could be neither. So for this example, we have two vectors here. So I like to do the orthogonal part first, just because it's kind of easiest. Okay, so to test for orthogonal, you're going to test the dot product. So I'll be multiplying 2 times negative 4 plus negative 7 times 14. Okay, this gives you negative 106, which is not equal to 0. So because it's not equal to 0, this means they're not orthogonal. So we're going to go and try the parallel. So the parallel says you have to find some scalar k that if you multiply one by it, you can get the other vector. So if I take 2 to negative 7, I want to find some number I can multiply so that I get negative 4, 14. So to get from 2 to negative 4, if I was to multiply that by negative 2, so negative 2 times 2 is negative 4, that works. Negative 2 times negative 7 is 14, so that works. So because we can multiply by this scalar negative 2 here, that means that these are parallel vectors. Okay. Just to make sure you're clear with this, you don't really have to pick a certain one to start with. So instead of doing this, I could have multiplied this one by 1/2, and this would have given me this vector right here. So as long as you can find some number here, or it has to be negative 1/2, but it give me some number over here to get this other vector, that's when they're parallel. And that pretty much covers it on the vectors.